This video covers compound probability, specifically unions, and we're going to be looking at a situation with a bag of marbles where we're picking two marbles and we're looking for the probability of when we pick one and we put it back, meaning we replace it, or when we don't put it back and we don't replace it. So for question one, we have 20 marbles. We have green marbles, red, and blue, and we're looking for the probability that picking the first marble is green or the second marble picked is blue. Now in this situation, after we pick that first marble, we replace it, meaning we put it back into the bag. And to calculate this, we're going to use our compound probability formula specifically for unions. I'm going to add in all my individual probabilities here so you can see the probability of picking a green one first is 5/20. The probability of picking a blue one second is 6/20. And then there's a situation where we could actually pick a green marble first and we could pick a blue one second, but we don't want to count that twice, so we have to subtract the intersection of that happening. And if we put that all in the calculator, we'll get 19 out of 40. That's going to be the probability of picking a green marble first or a blue one second. Now, the focus of this one is that all denominators here for all four of these probabilities, like within the formula, have a denominator of 20. That's because we are always picking out of 20 marbles total. And that's going to be different with some of the situations we cover next. So in question number 2, same probability. We're looking for the chances of us picking a green one first or a blue one second. But with this one, after we pick that first marble, we don't put it back. It's not going to be replaced. So we're going to have one less marble. Now let's bring in my formula again. We're going to use the same formula. And I'm going to add in all my individual probabilities, but you'll notice it's something different. Okay, but let's start at the beginning. The first probability we add is the chance of us picking a green one, so that's 5/20. And we add it to the chance of us picking a blue marble second, which is 6/20. And you're thinking, wait, we didn't put that first marble back, so wouldn't the denominator now be 19? Because when we pick that second marble, we only have 19 marbles. But in this situation, because it's just the probability of picking a blue one second and nothing else with it, we treat it as an independent event. And then we'll subtract the intersection, so the chance of us picking a green one first and a blue one second. And that's a possibility. But because the blue one is with the green one there, it's the intersection, it's something and something else happening, we treat it as a dependent event, and that 19 is there in the denominator because after we pick one marble, there's one less in that bag, so we're left with 19 marbles. And if we calculate that, that's 179/380. Now, I know that this one could be really confusing because of the 6/20 for the picking the blue one second, and then in the intersection, in parentheses, it's 6/19. And that's just the way it is. Again, I want to emphasize, because that picking that blue one second is 6/20, it's by itself. That's why we treat it as an individual event, like independent. All right, on to the next one. Question 3. We have another situation where we're not putting that marble back after we picked the first time, but this time we're looking for the chance of us picking a red one first or a red one second. And I'm going to add in my probability formula here. We'll use it again, and I'll plug in all my individual probabilities. So the probability of picking a red one first is 9/20. A red one second is again 9/20 because it's an independent event. It's by itself. The denominator stays at 20, and then when we subtract the intersection, the first probability of picking a marble is 9/20 because that's the red one first. And if we want a second one that's red, we have one less red one total. So it goes from 9 total red marbles in that bag to 8 because we didn't put that first one back, and then the total number went from 20 to 19. And that's because it's a part of the intersection. It's not by itself. And there is our final answer, 27/38. Which brings us to question number 4, which is a little different. In this case, we are just picking one marble, and we want the probability of it either being a blue one or it could also be a red one. So again, we're just picking one marble. I'm going to use my same formula though, and then I'm going to add in all my probabilities there. So the probability of picking a blue one first would be 6/20, and then if we also could get a red, that's 9/20, right? But when we subtract a 0/20, that means because we can never pick a blue one and red one at the same time. Remember, we're only picking one marble. So if we look at that marble, it's either going to be blue or it's going to be red or some other color. It can't be both. It just can't be blue and red. So that'll never happen. That's why it's a 0 out of 20. So there is no chance of that happening. There's no intersection that we'd be subtracting technically, because it's a 0 out of 20 chance of happening. So put it all in the calculator, we're left with 15 over 20, which will reduce to 3 over 4.